think we can get ahead and get started because I see that most of us are here.
Good.
Hi, good morning, everybody. I'm so happy so many people were able to join us. I wanted to start off and introduce myself. I'm Bracha, the General Manager of ParaGroup. We put this webinar together to discuss the importance of AI in the construction industry. This industry is one of the only ones that has yet to embrace the AI technologies, and in our opinion, it's of the utmost importance to begin this integration. This is why on our panel, we have Cary, who's an investor in our company, as well as a real estate developer. We have Craig Slama, he's a partner at Jablonsky, which is one of the largest engineering firms in Canada. And we have Ionathan Lazovski, he's the founder of ParaGroup, which is a leading company, which is our company, in the AI and construction industry. The questions we're going to speak about today are going to address the risks and the benefits, as well as the potential of AI in the design of high-rise buildings in North America specifically. We're hosting this webinar in meetings form and not panel form because we want to welcome and encourage everyone to participate. If you have any questions at any point, please let me know in the comments, and we're going to try to get to all of them. I also want to mention that we have our two other investors in the audience, Richard Borshiver and Ira Garshowitz. They're also available to answer any questions that arise. I, of course, want to thank all of our guests who have joined this morning. We have attendees from all over the world. I see people from Canada, Israel, UAE, Dubai, Spain, India, and the US. AI, as you all know, has no borders, and we're thrilled to have you all join with us today. With that being said, I would like to begin with our first question, which is to Ionathan. Ionathan, can you please start by telling us exactly how AI optimization works in regards to high-rise buildings and ParaGroup's technology specifically?
Okay, so Bracha, thank you very much for the introduction, and thank you everybody for being here and listening to what I am going to say now. I think that one of the biggest challenge about AI is explaining AI in less than 10 hours. So I'll do my best here to squeeze it into a few minutes just to give you the essence. And after that, that we'll have some clear understanding of what AI is. We'll try to figure out how exactly we go into optimization and how it can help our industry to be better. I'll have to say that's, I think, the best way to put it. So just to clear the ground, artificial intelligence is basically the science of creating machines that can reason, adapt, and provide solutions, which is a very big title. Those machines can do it in real world, like you can see robots and drones and all different sort of IoT elements that can do it actually outside, that they actually can connect with other machines or can understand their environment. But we can still see it in the virtual space as well, inside computers, and those usually are considered as computer programs. Now, it's very important to mention that not all the computer programs are considered AI. Only those who can perform human tasks that include reasoning at its core. That means that specific feature that we humans have, but inside a software or a program. In computer science, those programs are called agents. We're different in those programs from other programs because of the reasoning and because they're not just automation of tasks, but actually they can learn something and they can adapt according to the learning and provide us with some benefits. The question now that follows is, how can those agents help us in the construction world? We see that they know how to learn, they know how to adapt, and they can provide solutions. So at ParaGroup, this is our core business, basically. We develop those agents and we help engineers optimize and automate their design within their CAD environments. That means we can see that today you can see AI in different type of machinery, even on cranes. We have a few Israeli startups that use cranes, for example. But in our case, we take it more to the design part of the trade, for the engineers part anyway. So how exactly we did that? So let's use a specific case for like structural optimization. We know that today structural engineers have to design the structure. They have a amount of time and a specific knowledge for that. But what we do that can actually help, we build agents per project. That means we don't have an agent that can do all the projects, but we actually provide a specific one to get as optimized as possible. In other words, those agents receive all the constraints in the upfront from the engineers, such as local code and regulations, different loads of the structure have to take, the construction method, and of course, pricing. The engineer then will provide a strategy according to the architectural design, of course, because the agent has to understand what is the challenge, not only what are the constraints, but constraints of the structural design, but where can he act? And from that point, the agent will start iterating different design. That means he will redesign over and over the project. And those iterations will help him to learn how to improve the efficiency of the project, specifically in pricing, while keeping all the loads and regulations intact. That means not only we're able to provide a cost-efficient solution, but it's a valid solution in terms of structural design. Eventually, that agent that I just described is a game-changing tool for the engineer. You will never replace him, and I'll say it up front. It's not something to replace the engineer. The obvious is that it's a tool for the engineer that needs to provide his experience. The engineer have to have as more the experience the engineer has, the better the outcome, the better the optimization will be. The agent can accelerate the time while helping him reach a more cost-efficient design. In other words, in this case, AI is providing a value engineering in real time for the engineer to work. Instead of having value engineering later, the engineer has it in his own hands.
Perfect. Thank you, Ionathan. Thank you for that introduction. The next question is actually for Cary and for Craig, and I think we'll start with Cary. And the question is about the greatest risks and the greatest benefits, in your opinion, when using AI optimization in high-rise design and high-rise development. So, Cary, I'll let you take it away.
Well, why don't I start with the risks? It's a great question. Everybody asks, like a job interview, what's your biggest weakness after you tell all the good stuff? In effect, there really aren't any risks that we have here. It's value engineering that's being done. It's being done under the auspices of your lead structural engineer. As Ionathan had just said, every single decision or equation that the AI algorithm is doing works within all the constraints of every law, bylaw, code, you name it, that we have to work with. So in terms of risk, that's taken out. The benefits that we talk about, not just purely as a developer, is savings in time and material. The big material the big savings in material, and if we can reduce our steel, our concrete, our forming, anything like that, between 3 and 15%, those are huge. And the savings that those bring to the job site are massive. And when you look down the line during construction, the cost savings are obvious there up front. But when you start looking at the impact on the jobs of shorter time with street occupancy, less trucks on the street, more fluidity on the job, because I don't know about everybody else, but if you're building in Toronto, our sites are so tight right now. Almost all of our sites are street occupancy, and that limits the project, because you can only have, when you're unloading a flatbed full of steel, that's taking up place that other trucks can't come in on. So the sooner you get the major trucks out of there and you reduce your occupancy and your savings on security, et cetera, it all adds up to costs. Speeding up the overall project by having the design move a lot quicker just gets us through the project that much quicker, gets us into rentals or gets us into condo sales. So everything works, everything goes straight to the bottom line. And I'll reiterate, I don't see, from a developer's point of view, I don't see any risk. I see pure benefits. And it's about time our industry started bringing AI into it, because we really are probably the only industry in the world that isn't availing itself of technologies that are available today.
Great, thank you. Thank you so much, Cary. Craig, as a structural engineer, I'd love to hear your opinion about the risks and the benefits from your side.
Well, structural engineers typically are a bit risk averse, so I'll talk about risks first. You know, as a structural engineer, your main concern obviously is the safety of the structure, and you know, will any new technology potentially cause structural failure, cracking, deflections, vibrations. So the scheme, the way it's proposed, is there's absolutely no chance of any of that. You know, the idea is that you provide a very optimized schematic framing scheme. You know, the columns are already rough, sizes are all set, everything's set, slab thicknesses are all set. But then it comes back into the structural engineer's hands, whether it's me or someone else, and we actually design all the elements, and we can have a back and forth with, with this technology to understand, perhaps why they thought things work where we think they don't, and we can then design it, ensuring that it meets all codes and all safety factors and everything is all in place. So there's no risk of any structural failure or any structural negativity. In fact, there's potentially a risk that when we're designing these elements, we would be a little too conservative in our estimation, losing some of the value that the AI has provided. So if we feel that the AI has maybe been a little aggressive in a column size and we start increasing column sizes to make up for it, the risk may actually be that we start to unoptimize some of these optimizations. And the benefits, well, I mean, the benefits are huge. Obviously, the way computer programs are set up nowadays, it's very iterative. So it analyzes a set scheme. So if I want to analyze a building, I design how I want the walls, I run it and see how it works, and it works, and that's great. So then maybe I reduce the wall by 6 inches or 8 inches or 10 inches or a foot. Each one of these takes man hours and it takes a lot of iterations, and the results aren't anywhere nearly as comprehensive as possible. So basically, the state of the computer software nowadays and the available man hours that we have sets you to getting a design that is as efficient as possible, but certainly far from optimized.
Okay, great. And then again to Craig, as with any technology, its adoption might face challenges. So as the structural design, workflow, and collaboration will be affected, as will the traditional timelines for the drawing development. So how would you address this as the engineer? And then obviously I'd like to hear from Cary afterwards how he would address it as a developer.
Certainly, implementing this kind of thing, you want to do it very early in the game, and there's obviously soft costs involved in developing a floor plan and a building to a certain extent. So commonly we do very little work up front, certainly not optimizing it, but that really is where your bulk of your structural savings would be if you were able to run it in front. So I think the entire workflow needs to be modified a bit, and not just the structural consultant and the owner, but also key obviously would be the architect has to understand that maybe the timelines and the processes have to change a little bit before we can start releasing marketing material or start doing black lines for suites and things, just to make up a lot of that optimization to let it be available. There's only so much optimization you can do once suites are sold, obviously.
Okay. Ionathan, do you want to add anything?
No, I'll let Cary, and then I think I'll
Okay,
add.
I'm just trying to get some more light in here where I am.
Sure.
Thank you perfectly, Cary.
Hopefully that helps somewhat. Nope.
Great.
I love it.
You look great, Cary. Cary, so tell us from your side, how would you face these adoption challenges and the collaboration?
Well, the good thing is, first of all, they're new. Let's start with the broader appeal of bringing AI into what we're doing. I would have to say that if you look at the most common AI that people are exposed to and think of what Waze did for urban navigation or driving on road trips and stuff like that, And I just want to know if anybody here would think of, you know, going back and pulling out a Pearlie's roadmap or the little flip maps or road things and trying to get your way through the city. Nobody thinks twice. You push a button, you put in your destination, you go. And that's what AI has done for that industry. For this industry, speeding up the processes that were alluded to. And it depends where you want to get into where you want to inject this into the project. But all of us know, or most of us experience, that once the architecturals are done to a certain point, and then the structural engineer has to come in, and towards the end, there's very little latitude left for what we want to do. So we need the value engineering for the structural engineers to interpret the architect's drawings and run this while we're doing it. Later on, and some of the things that we've actually discussed, is that if there's small areas where suites need to be changed for whatever reason, and you're way down the line, you're into sales, you're doing stuff like that, we can go into individual sections and optimize the slabs, the columns, the walls in those individual areas, and because don't forget, every change, I don't care, you're up on the 32nd floor and, you know, unit 1D, whatever it happens to be, any change you make is going to find its way all the way down to, you know, your P2 level. So it's really, really, really important that we are very sharp and crisp on those changes. So we have the ability to optimize and not spend months, because if you could imagine trying to figure that out, if it was manpower doing it on its own, how long that would take. You now have the ability to bring AI into this at different times in the process. So we think it's great. It's new to most of us. It was certainly new to us, but we come from the position, and we're apartment builders, right? So we're on a thinner edge than most builders, but in apartments, and especially affordable rental apartments, you know, we're razor thin on our numbers, and so we want to avail ourselves of every technology we possibly can to keep those costs in control and to have the most cost-effective, you know, long-lasting buildings that we can produce.
Amazing, great, Ionathan.
So, well, there's a lot of the just was said, but I'll add a few things that it's important to say that another thing that AI has, it's its own flexibility according to the situation. And I think that from my experience so far with the Toronto market or the Canadian market, when you go into a specific project, that project can be for rentals or for sale, as you said, and it changes schedules. And I think that one of the interesting points is not only we help, or we provide a tool that actually helps the engineer to get faster in track, but actually to help not only the engineer, but actually the developer itself to take the correct, let's say, path. For example, if we're talking about selling apartments or rentals, okay, where you have more flexibility usually because you haven't fixed the unit size, and you can make some changes. And for example, I'll say your marketing the department tells you, you know what, perhaps we should change a little bit the design when you're in a more advanced stage. And changing the design is something that takes time. And not only takes time and of course budget, it actually puts a lot of pressure on the project because you actually need to deliver, but you still have that hunch that perhaps you're doing something here and you want to evaluate it. Now, in the best case scenarios, Craig, which is an excellent engineer, will manage to pull it in a few days, make that change. And we're talking about not days. Let's talk about minutes. Let's talk about an hour tops. Let's have the ability not to evaluate one change, but many changes. To be more aware of the possibilities we have and let the AI help us not only make it faster, but actually providing us with the optimal and the cost at that point. That means we can actually have the cost figure out up front, which is, I think, one of the most important point of AI. AI not only help us optimize and make things faster, but it actually help us to take the right decision. And sometimes the right decision will be to make the construction site, the construction phase, a little bit more expensive, but perhaps when we'll sell that apartment or that building, we'll be able to sell it for a larger revenue. And that is something that doesn't mix only the engineers, but actually the knowledge from the developer into the process. So we can say in a way that the AI actually creates a new type of connection between the engineer and the developer, which I'll say from my experience in Israel, for example, in Israel, the situation is a little bit different. That's not a good situation. Usually that point is a point of friction, where the developer always will argue with the structural engineer that he used too much concrete or it doesn't fit the unit that he wanted. And instead of that friction, we can connect these two professions. And we saw it here in Israel that we actually managed to take these two guys that usually will, email each other with bad words, now talking about movement, talking about let's move 50 centimeters to this side, let's change a little bit, because they have the ability to make it fast and to be aware of what they're doing. So I think it's more from the point of cost and speed. It's connecting people, and that's, I think, the greatest thing about AI today. And I think that we can all see what technology is doing now. We're in 7 countries we have in Bracha, I don't know, and we're all at the same time, thanks to technology, can actually make the entire thing optimized in the same way. Even using Zoom, we can optimize projects worldwide, as we do, because we provide the service from Israel to Toronto or to the Gulf area, and it works. We have the ability to do that. So I think I talked enough, Bracha. Back to you.
I know, Craig, you mentioned this briefly, but I just want to reiterate, as the structural engineer, do you see any risks of structural failure as a result of using using ParaGroup's AI technology?
Certainly not. I mean, it helps develop schematic framing schemes, and it gets, but all the final design is always in the hand of the structural engineer. So, we're still stamping it. It's not like, we take the drawings from the architect, send them off to ParaGroup, and working drawings come back to us all detailed and everything, and we just sort of stamp them and collect our fees. It's really, if there's any chance of structural failure, it's still running through the hands of the structural engineer, who has to sign off on it. So, there's no chance.
Okay, great. Ionathan, actually, this question's for you. As we do have an international audience here, and our AI can work all over the world, how specifically is AI learning affected by past designs? For example, with different codes in different countries or regions, is there perhaps a risk of the AI learning optimizations in one region and trying to apply it to another region where it would actually work against the optimization algorithm?
Well, it's a question that I know from where it comes from, because we've been asked before, because you have different type of AIs, and the way that AI learns how to behave or how to provide its outputs differs from place to place. When we approach a project, no matter the territory, we always take the local regulations and the local codes as a base. We'll never give our algorithms to learn something that's a different code with a different code. That means it's the basic of what we do. And that's one of the things that allow us to provide a more optimized solution, because from one hand, you can take, let's make an example, you can take all the structures in the world and build a database from them and tell your algorithm, okay, that's your database, and learn from that database and give us a new solution for each project. That might be in some ways problematic, because all the structures in the world, each one is designed with a different strategy in mind, of the engineer in his mind anyway, and that cannot be a learning material. That's why we picked specifically the iterative learning. That means that the algorithm will go specifically for the specific territory, code, load, and project. Not even if you'll have a project next to the same project, in some cases you will have different strategies by the engineer, and the algorithm will behave according to those strategies and will specify those codes. So it will start redesigning over and over within the boundary that we set for that specific project. So in that way, we secure two things. First of all is the fact that we have no faults in terms of physical faults like loads and so on. that we haven't missed any type of regulations. And the other thing, that the engineer at the end gets something that he can rely on. That means something that looks similar, something that seems something that he would think about, but it will take him, I don't know, 300, 400 iterations to get to. That's basically our aim. It's to take those iterations using his strategy and the regulations and giving him something that he feels comfortable with. Different engineers feels comfortable with different aspects and different schematics. So it's something that has to do with the algorithm, that we need to understand the human that's making the design, not just creating an a superficial algorithm that will say, okay, this is the way to design something. No, he will never get an optimized design. Specification in this case is the key to get to the best optimum and to get a result that the engineer will immediately be okay with.
Okay, great. And then I actually want to pivot back to Craig for a moment. I know you mentioned this briefly as well, but I'd like to hone in on this idea. How would you address the issue of structural engineers feeling uncomfortable with the optimization during the design phase? And I know that you mentioned overcompensation, but how would you reduce that nervousness?
Well, I guess it comes down to familiarity with the process and the software. At the start, especially if you're talking about reducing concrete volumes by 10 or 15%, most structural engineers probably are going to blanch at that idea. They're going to think that no, we haven't been that far off, and maybe we have or maybe we haven't. But the more iterations we go back and forth, and the more chance we get to actually design buildings and see how they work with the AI technology's suggested framing, the more comfortable we'll get. So it's just going to be a matter of a bit of time. But of course, the slower the engineer is to become comfortable with an optimized solution, if other engineers are become comfortable much quicker, you'll find a real trend in the one engineer's designs being severely overdone. So we all have to adopt the technology reasonably quickly, or else we'll become uncompetitive as engineers, basically.
Okay, great. And I was just wondering if anyone has, I see Alan has a question, and Alan, if you'd like to just ask out loud, that's fine.
I guess you might have to listen to my dog in the background, sorry. My question is about the constraints and about the local codes and how hard it is to actually put all of that into your system, because you're doing some sort of mathematical optimization. So you have an objective function of some sort, and you have constraints, and your objective function must be something related to cost. Of course, you have to put that in properly. And then there's something that may just be more kind of hard to measure, the aesthetics, the function. And maybe your presumption is that your trade-off is going to be, you're going to make very small changes. So maybe an inch or two here or there isn't going to make a difference to how something looks or how something works. And maybe you'll still be able to get the duct work or the conduit or the drain pipe or whatever it is in the envelope that's remaining. But how it would seem to me that that's a very hard task, to just really model all of the local codes that might differ from region to region, and to really capture all the elements of what the architect who's got this look concept and function concept in mind, before setting your optimization engine loose on how to save cost, to skinny things up either with steel or concrete or whatever. How do you, that to me would seem to be very hard, yet, or am I overstating how hard it is?
So thank you for the question, Alan. It's a perfect one, because in most cases people ask the same thing. But I'll start by stating the fact that our team, first of all, is composed of architects and civil engineers who know how to code and use AI. So as to begin with, it puts it in a way that we understand the parameters. We designed them back in the days when we were architects and engineers. And now we are programming those same parameters, same constraints. So it is hard. That's the reason why we don't have too many companies like our company, or what we do is part of larger engineering firms. But that's I think the key point, that we don't need to put all of, for example, if we're talking about pricing or we're talking about constraints, we don't need to use all of them. We need to use only the ones that the civil engineer, or in this case, the structural engineer, will be using. That means Craig, as a professional, uses specific, let's say, constraints that he knows that they're okay. We don't need to go further than what he uses. That means inside of his scope, there's enough information. It's hard enough. But one of the things that structural engineers always help us in the project, they direct us to what we need to add to the algorithm and what shouldn't we add, because it's not relevant for this project, for example. So we don't need to add the entire pricing book of, let's say, Toronto of concrete elements, just the ones who are more related to this type of projects. And the same thing with the local codes. For example, earthquakes and winds are very tough to calculate, extremely tough to calculate, but still there's some abstraction that we can use together with talking with the engineer to how he abstracted in that specific preliminary design phase, let's say, how we abstracted, and we can use it and we can model that inside of our functions. So yeah, it is tough, but it's the right team in this case. And we have the engineers that can actually simplify as much as possible the task for us. So we won't need to, months and years of calculate everything, but that takes us again to the specification, the specific project. The engineer will help us with a specific project. And in every project we'll go in, the engineer will help us in the same way. And it's not too much work from the engineer. That's, I think, encapsulate the concept of the strategy of the engineer that we always need, that mind of the engineer, the way he works, and put that mind into the AI to actually create the specific tool.
Thank you.
Question that I have is regarding the program. I understand the process optimization and so that's normally done manually to some degree, but now is the system providing total specifications and drawing once the configuration is established? And
yes.
The next question is how do you overcome the hesitancy of the approving authority? Or it's just rely, I don't think you can rely only, with all due respect, on the engineers. It has to be approved by the city or whoever. How do you interface? How do you do that interface?
So in measures of the first question, yeah, the entire calculation or the entire iteration done by the AI is on a specific model. That means it creates the model, it analyzes it, and then it goes on by iterating. So eventually at the end, you have a model or even a few three-dimensional models. If you're working in a BIM environment or a CAD environment, you have a model generated for the engineer. So we'll have a model. And in terms of the second question you have, in terms of how the city will accept it or not, I'll go back to what Craig says. Eventually, it's the engineers that pulls out everything and sign everything and submit all the system, all the papers, I'm sorry. Our work is to give them the best tool to get to the highest point in terms of optimization and time. He's the one responsible, he's the one to be in front of the city in order to get approval. And moreover, all what the system does, it's within the region, the code, and the strategy that the engineer imposes us. So we don't do anything that has to be outside. Everything that will be generated, it's something that the engineer will feel comfortable with, will be reasonable. So we'll look at it and at first sight, we'll see that it's a reasonable design as well, not something weird or, I don't know, too sporadic. Everything that will be done eventually is under the copied, let's say, mind of the engineer inside the algorithm.
Thank you.
I have a question I was hoping I can ask.
Sure.
I think we've got Len Abelman up next, and then
Oh, yeah.
Sure.
Yeah, let's get Len, if you don't mind, if you want to unmute yourself and ask your question.
Well, hi, everyone.
Alon wants to ask a question?
Yeah.
Okay, great. So if you'll go after Greg. I just want to say, and maybe we could say it right now, we're scheduled to go till 9:45, but we can stay on till 10. So if people have questions that we didn't get answered during that, so no problem. But by 9:45, you should be fine there, Alon. Go ahead, Len, sorry.
Okay, thanks a lot. Hi, I'm Len from WZMH Architects in Toronto. I got two questions. One's a software and one is an optimization question. So first of all, is this, practically speaking, is this a plugin to Revit or AutoCAD? Like, how do you plug your software into the systems we use?
Okay, so a very practical but a very needed question from my point of view. Yeah, we provide for each project, we provide a plugin that will specifically solve that project. That means the plugin is usually a single-use plugin because we want to tap into the environment that the structural engineer is working in. So if he's working in Revit or Tekla or ArchiCAD or different BIM or even two-dimensional models, we can tap into that environment and he will make his choices there. That means where he would like to have the columns, for example, the schematics, and our plugin will run through that information and keeping him in the same place is already working. That means we don't want to take him out of the software and in again. That's not the job. The idea here is to keep him in his software, in his comfort zone, and it all the iterations and all the solutions specifically there.
Okay, so my second question, can your software optimize transfers? Like, you know, when we design residential buildings, we have one module for the residential units, and then we come down to the ground floor and the parking, and then we usually reconfigure our structure to optimize for parking. It would be fascinating to see what AI could do with that. Is that something that your software?
This is the best part of it.
We all know that most of the cream, as we can say, cream sits in the transformation slabs or columns. So yes, that's one of the biggest one. That means how do you see the system actually sees not the building as a set of elements, but as a system. That means when the system will change something in one of the iterations, will change one of the columns or the column or the section or the size of it, it will evaluate what it does to the transformation slab under it. Because, for example, if you move a column, of course, that will make a lot of change if that column doesn't go directly to your parking lot. And unfortunately, in most of the cases, it doesn't because parking lot have their own size and apartment have different size. You would like to know what it will do to the transformation slab. And that's exactly the point where our algorithm is very efficient because you can reduce the column and the slab thickness of the apartment, the unit. But if you manage to take 10, 20 centimeters from the transformation slab, that's huge. That's a lot of cream there. And yes, our algorithm is specifically looking for how to do that as well. So in terms of transformation slab, it's not only about pricing. That means not only you reduce that and it's less concrete in the product, but actually can gain more height in specific floors, something that architect usually would prefer having. If you can have more height, it's better for everyone. Or perhaps take the building a little bit down lower, depending on what you choose.
Thank you. Very interesting.
Great. I see Garrett has a question, and then also if we have time, we'll go back to Alon. And obviously we can stay on for longer, but Garrett, want to go ahead?
Thank you so much, appreciate it. I don't know if you guys can hear me. I'm calling from Puerto Rico, and I just have a question in relation to how AI technology might be used in disaster resistance situations. So being able to model situations with hurricanes, earthquakes, obviously that's something very relevant to construction in Puerto Rico. I myself am a neurobiologist, so I'm very aware of the role that computational neuroscience and computer science has played in the role of development of AI technology. And I think this ability to be able to model systems under certain constraints is really interesting and favorable, and be able to come up with best possible solutions both on the economic side and function.
So that brings us back to the point of specification. That means if we need to design a building and there's more constraints, for example, that has to do with hurricanes, and you can provide, or then your engineer works with specific equations, because eventually he needs to have some equation to calculate, is the building resistant to a hurricane? We haven't done it yet, obviously, because Canada, they don't have hurricanes, or Israel. As long as there is an equation in the background, we can put it inside in the system. The AI will actually take into consideration, and it will be part of its function, of course. So anything that comes to mind, that means we're always looking for more and interesting modifications such as this, for example. Yeah.
Okay, great.
And just to, thanks. Thank you.
Oh, sorry, go ahead.
No, just a follow-up question, and obviously this is applicable to any type of buildings, right? We're talking about main houses, but something like construction of greenhouses or other applications, right? This would be possible for.
I think that in terms of what type of project is more about the let's say the costs, because if our
cost benefit analysis, yeah.
If our services it cost X and it reduces X minus 10, it won't be beneficial to nobody, not yet anyway. But if again we're talking
Excellent.
about high impact and costly, yeah, we can do a lot of improvement there.
Okay, hi guys.
Thank you.
Before we continue, there's quite a few people who still have questions, and our panelists can still stay on for a few more minutes and answer any questions that you have. But if anyone has to go, I know it's Monday morning, and I just want to thank you guys for joining. And anyone who still has questions, if you have time, please stay on. And if you don't, we will definitely email you back later, privately answer your questions. But so I just wanted to say that. But Alon, I wanted to get to you if you're still able to stay on and ask your question.
Sure. My question, actually Len stole one of my questions in terms of how does the software plug in, or is it an upload type service? But so that question was answered. My other question was in terms of optimization between materials. So let's say we have a building that is initially designed as a cast in place concrete material, and we're looking at potentially going into a steel frame, or maybe it's a low-rise building and wood frame might be something that is an option. Would the software be able to switch between materials to say, this is what it will look like if it was concrete, but it could do this if it was steel?
So the answer for that question is yes. I'll just say that for the moment, our algorithms are focused on concrete, but we have no problem turning them into steel or wood. I'll just say that it will take us some time of development, and it will take time and a little bit more effort from our side, but yes, it definitely is, because eventually concrete behaves in a certain way, and I'll say that concrete is the most complicated one to calculate, by the way, more than steel and wood in most cases, because the way you build, or the way you execute concrete structures. But yes, if there's structures big enough that we'll look at them as a good potential, why not? We'll be able to develop as well. Yeah.
I'm guessing it's complicated because it's two materials, right? It's the steel and the concrete interacting together in one solid material. So a brick building would be like a nightmare.
If it's a mix between where to put steel, where to put concrete, well, that will be a challenge, and still is, by the way, but not something that we can tackle. We can actually tackle that. It will take us some time to develop. And it depends. If the project, we went automatically to concrete because concrete is, it's more, in the most cases, is the used material for structures. But yes, we can do that as well. It will take time, that's all.
Okay, thank you.
Okay, great. Matthew.
I think Samrand was up next. Samrand was up next.
Yeah, also, yeah, Samrand. Yeah, go ahead.
Hi, I hope you guys can hear me. I'm just joining via my phone. Can you hear me?
Yep.
Yeah, we can hear you.
Okay, perfect. So my question is, I understand the AI uses algorithm to find the most optimal design by using local code regulations and apply loads and etc. But what I'd like to kind of divert the conversation onto the site, because I'm a project manager, and for me, one of the most important things is cost and schedule with everything, with every decision that I have to make. I understand there's going to be a lot of cost savings, right, from formwork perspective, concrete placement, rebar placement, and concrete and rebar supply. But one of the other things I want to, I guess my question is do you take into the consideration of the site interferences? One of the issues that we have on the site is lack of coordinations of the drawings, such as, for example, let me use electrical conduits, mechanical sleeves. For example, on the ground floor where we have a lot of transfer slabs and beams, we tend to have a lot of mechanical issues, interferences. Does that take that into the consideration, your design?
I think that we can answer, the three of us, each one from each side, but in some way, we are limited to what basically the structural engineer, let's say, is doing, and not above that. That means it will be very hard for us to consider what happens on site or tackle problems on site. That will require some very specific strategy from the structural engineer if he wants to do that. I don't know, Craig.
I think the main thing to remember is that you're not providing structural drawings in the AI platform. You're providing a framing scheme. So the structural engineer still has to do the normal coordination he normally would. He still has to go through and provide the duct penetrations that are there. He still has to understand the construction sequencing and where you can fly forms or how the formwork can be assembled and disassembled. So that the level of coordination that you're seeing on site isn't going to be improved or hurt by the AI. That's strictly a function of your consulting team and the engineers involved and the timing of all of those elements. The one thing, though, that we do probably need to be a little more careful is in an optimized structure that's optimized to this degree, in a way we have to make sure we coordinate a little bit better, because suddenly if a wall is, instead of 3 meters long, it's only 2.2 meters long, maybe we can't just put a duct through it. Maybe we just can't put a big hole through it. So the structural engineer maybe needs to have a little more level of care when he's coordinating it, but basically the same problems that are there normally will still be there now.
Okay, thank you.
Thank you, Craig. Matthew and Randy, I see you wanted to ask a question.
Thank you. How you doing, everybody? I'm curious if your intent with this new product will be approaching, or AI will be approaching the major cities. If, let's say, you're in Ontario, to get them to implement it so it works coaxial with what engineer you're doing. In other words, there's a lot of plans going to city, going for review, not approval, to speed up the time if they can do it. Are you approaching cities to put this in so it'll be also on the same system, in other words? Or do they just trust Jablonsky's stamp and say, yeah, they said it's fine, so therefore it's fine? Is your stamp sufficient?
If I may take this, Ionathan, depending on which municipality and which city you're in Ontario, they either blindly accept it or they don't really care whose stamp is on it, and they will review it to death regardless. So the AI process gives you a starting point, but the final design goes through the structural engineer anyway. So the structural drawings are produced by the structural engineer, all the rebar is detailed, and the poor structural engineer is going to fight with the city or with the municipality to get the approvals regardless. AI optimization gives him the best possible starting point. And when I mean best, I mean the most optimized starting point. So the city will never see sort of the AI algorithm. They will just see a reflection of the final design that's based on that algorithm on our drawings.
I see. And if they don't understand this, or do you think you're going to get pushback?
Well, they won't. They never. It's not so much that they will not understand it. They will still see the normal calculations we always do. They will still see the normal software, the outputs, and everything. We may get pushback if the you know, if they're suddenly asking why walls are thinner or why beams are thinner. But typically the, you know, the plans examiners, as long as you meet the calculations in a way that they're not used to seeing, they will approve them. They're typically, at least in our local market here, not quite sophisticated enough to recognize that, hey, you know, on the last 40-story buildings, your walls were 350. On this one, they're 275. What's going on? I don't think they'll see that. They're just going to see the standard output we normally give them in the standard drawings, and it'll all be designed.
I see. Follow up too on it. Do the trades, being HVAC, M&E, mechanical, like plumbing, do they need to be on this system to understand what you're doing in terms of fixing things in place? Does it allow for that coordination? Or do they have to have AI?
No, they don't. In other words, I'll just say that in the future, as we see, we're in the present, we're just starting with AI in the construction world, but in the future, you'll see that the same way that AI helps Craig in the structure, you can see the AI helps other MEP or mechanical engineers in the same format, and it can even help them connect to each other in a better way. Platform-wise, it's going there. That means you see more collaborative platforms for designing today, but it's still just getting in. That means something that moves pretty slowly and just getting into the market. That means that you have an architect and his advisors working on the same model together in a connected environment. It's something that happening, but it's only the beginning. So the moment that will take more speed and will be more of the way things are done, that's where the point for us to go in. But at the moment, we can tackle one specific narrow, you can say, objective of the design, and the bigger one, I think the most important one from our side, because concrete is a big chunk of the project. In some cases, a third even of the overall cost of the project. So, and at the same time, yeah, there is a lot of human intervention here from the side of the structural engineer that has to know how his MEPs are going to work or what they're going to do and calibrate his strategy so our algorithm can actually provide him time after time the needed solution, a good one anyway, in these terms. That means, as Craig said, if there is a change needed to be done in one wall because that wall needs to carry in a duct inside of it, okay, we can actually strategize around it and say, okay, the sections should be not less than that size or that size, so we can accommodate ducts or so on. So there's as much information that the structural engineer can provide us, we can actually be more specific to the need of that project and to the other consultants. But it's a process. It will go in, it will grow as we work. That's the thing about AI. AI grows. And Cary just mentioned before Waze, for example, that everyone takes Waze today. But if you use Waze 8 years ago, sometimes Waze will send you to other places. Because that's how AI works. It grows and matures and becomes better and better with time.
All right, I just need you to help me through one more thing. Matthew wants to ask a question. It won't take long, I don't think. How's the interconnection working between the architect and the engineer? Given in our city, or most bigger cities, I would think, Cary has better experience downtown on this, we're really dictated by a footprint and the design of the architect to maximize what units you get on your FSI and your coverage and all that. Has to be in coordination to what the engineer is going to design relative to what he's designing to what you have to sell. Does both the architect and the engineer need this format together, or can one provide it to each other?
Great, Cary, would like to take this one?
I mean, Greg can give the technical answer, Rand, but to the bigger picture, does the, you know, starting with the building or starting with this, whatever the city's asking for, we work within the general constraints of whatever setbacks guidelines we have. This the AI will optimize the structure at that point. It may come up with some things. For example, that we may say, hey, you know what, let's go for a minor variance on this. Like, right, you know, because you know how crazy is the city. Move something 6 inches, you need a variance for it. But if it's something that plays out economically, it makes sense, then we may follow that. But it will respond and it will do its initial work within the constraints that are plugged in. It won't take it won't take, what's the word, I can't think of the word I'm looking for, but anyhow, it won't take liberties with fixed constraints the way we would as humans. It could be asked, you'd say, hey, if we had XYZ options, could we make this better, make it more efficient, make it more cost effective? You can run that and then make a decision on whether or not it's worth to pursue.
Yeah, I'm just curious again how the interconnection will work between the architect, the engineer. You know, you're building a lot of stuff, Cary, that you can touch all 4 walls if you're inside. You know, it's right to micro inch to what you need for space, et cetera, et cetera. How do you need layout, furniture, all that stuff. So is it not necessarily you can figure out a structural scheme that's better? It sounds like it would gain space, actually, so that's good. Yeah. Would it cause, by doing you the favor of telling you how to build it better, interrupt your design for that small space? That's the only thing I'm saying.
I'll let Greg, who's now Gordon Tattle for some reason, the answer, but basically it's basically about the coordination and where you step in between the architect and the engineers. We like to do right now, we're doing as a very preliminary one. When the architect comes up with his first, you know, couple goes around, you know, massing and everything like that, we can take those drawings and go in, develop optimized column and wall locations, slab thicknesses, etc. Right at the beginning, so that you're already setting the building off to it in a better position as you go farther down the design. And then all these other questions that come in, you know, where do you breach in the walls for your wires, for your mechanical, for your plumbing, etc. At least your base is in a better place to start with. And then the key question that someone asked earlier about dealing with transfer beams, like Randy, you and I over the years, like that's our major nemesis in life is transfer beams. Right at the beginning, you're aligning your building as best possible to minimize the thickness and the size of those and complexity of those transfer beams. So it's where you get involved in the project that makes a big difference. Sorry, I'll turn over to Gord Tattle now.
Matthew's there now. I'm satisfied. Yeah, go ahead.
I think like with any new and disruptive technology, we have to review our workflows and it's going to be a key collaboration with the architect and the structural engineer and the developer. The nice thing about an optimized structure, besides the fact that as a structural engineer, I like optimized structures, the nice thing is that you would at least have a baseline. And if you have an optimized structure, but it results in suites that can only sell for a square foot of $850, well, so you unoptimize the structure a little bit. Now you have suites that can sell for $1,000 a square foot, but you can compare those costs. You can compare the value and the net benefit much easier. You can say, okay, so our structure is maybe not optimized, but it allows us to get a much higher selling price. So that's obviously a smart decision. So I think, again, the earlier that the AI is introduced, the more flexibility we have to work, one, within the massing envelope the architect provides, but also, as Cary said, to perhaps find if there are giant cost advantages to somehow tweaking the massing envelope, whether those are worth pursuing or not. So again, as we start implementing this and working through these workflows, I think we'll optimize the workflows, and there might be some hiccups along the way. There might be some pagers or fax machine kind of developments along the way that sort of stutter through a few iterations, and then we realize that there's a better way to do it, right?
Gotcha. So just to that end, you spoke of the fact that it's disruptive and it's new, and as the example of ways that grew with time to become more effective, is there going to be some quality control procedures for a rollout so that we all can sleep well at night, in simple words? I mean, it's great to optimize, and obviously a prestigious firm like Jablonsky is not going to cut corners. I understand that. But a an error that could be done by the AI, is it subject to any form of auditing so we don't have a problem?
So again, everything that comes from the algorithm to us is then put into our own computer programs that we normally use to do all the design, and fully verified and fully designed and optimized. And if there is some element that needs to get a little bigger or needs to have a little more rebar, then like the AI solution that is coming to us is, call it like 95% baked, but it still has to be touched in every aspect and every single element by the structural engineering firm. So it's just sort of taking some front end work out of the system. All the final design still is subject to an actual, proper design, fully structural, accordance with all the codes, all the software, and so on.
I'll just add to that in that case, and from our side, from our developing team, one of the things that we like is to see what we provided and what was the end result by the engineer. That's something that can teach us a lot on how to actually make our algorithms even better in points that we didn't think that should be touched, and we can add more and more parameters. That's something that can help us actually develop along the way, and we're very interested in that point. So again, we can make it better and better for Craig all the time as we go, or for any type of software engineer, as we can learn from what they actually do with what we output to their software.
Okay. And then if people are still on board, Zachary, I see had a question. If you're still around.
Yeah, hi, thank you. So I kind of have a multifaceted question here, but I think this has been a quite interesting conversation. I think typically when you hear AI, you think about automation, but it's interesting to see that this is really an iterative process, and it's there's a symbiotic relationship between the engineer and the AI software. So my question would be kind of threefold. So number one, who's your client? So is your client the developer, or is it the structural engineer? If it is the developer, this is really for Craig. Craig, do you think that getting engineers to buy into doing this will be easy, or do you think there will be pushback, that some will be reluctant to want to actually engage in doing something new? And then number two is really for Ionathan, is because it's such a symbiotic process, and you've mentioned a couple times that the better the engineer understands the program, the better the results will be. How do you guys actually train engineers in different jurisdictions to learn how to use this, and how does that process work?
I'll start from the end, because we don't train anyone. We don't train anyone. That means that the engineering doesn't have to do anything specifically with us. That means we tap into the way he works. For example, if Craig will lay out down the way he wants to, or where he wants to put the columns, the system will automatically generate the cross sections, for example, and the slab transformations. That means Craig will always be putting some elements, telling the AI, okay, take that situation, now optimize it. So it's nothing about from Craig's side to learn, and that's something very important to us. That means no learning curve is very important for us, because if there's a learning curve and Craig have to do something more than he's already doing today, we are in a losing game. He wouldn't want that. No engineer wants more work. The contrast, we want to facilitate as much as work and let him focus on the creative part and the puzzle cracking and that stuff that engineers love doing, and less about the drafting and the iteration, which takes time and makes just exhausting actions. So as much as possible there. So in that term, the engineer doesn't have to learn anything from our side.
So would you say an engineer who has 1,000 hours experience on your software versus an engineer who has 5 hours experience on your software will be able to yield the same results in terms of savings in material and rebar? And
yeah, but I'll explain. I'll detail a bit. It's about the experience that the structural engineer has in structural engineering, not in using our software. That means as more experienced the structural engineer is, that means Craig has, I guess, thousands of hours of designing structures. So he has a better, or his strategy that he will impose on the system have basically better chances to get to a more optimal result, because he sees more things and he can constrain a few more points and add more heuristics into to the algorithm. So in that point, yeah, the experience is a civil engineering experience, not a software experience in that manner.
One thing I would probably add to that, it's you know, whether you have 1,000 hours or 5 hours with the software, obviously at 1,000 hours you're more comfortable with it, and you're perhaps, you know, you've realized after 1,000 hours that the AI output isn't, you know, generating things that don't make sense. So as I mentioned before, you know, working together and seeing these through several different projects, several iterations, and getting comfortable, and like Ionathan said, maybe of actually having the feedback of the structural design converge with the original AI design, you know, these processes will improve. Certainly though, your question of who the client would be, and if the client is the developer, does pose a very interesting question, and that really is a question for your relationship with your structural engineer and your other consultants. If you look on any structural engineer's website, you know, one of their main goals is that they're the single most structurally efficient design firm in, you know, the city or the world, right? But it's not just my firm. Every firm in the city and every firm whose website I've ever looked on happens to be the most efficient firm ever. So you know, it's going to take some pushback if someone comes and tells us, well, actually, you know, you may very well be the most efficient, but you're going to save 10 or 15% of the structural volumes here and the structural costs. You'll get some pushback from the structural engineers for sure. But in the end, the structural engineers who, you know, don't adopt something that provides meaningful cost savings for the end user, obviously are going to suffer as structural engineers. Like, I can't remain competitive if my competitors are typically, you know, providing designs that are 10 or 15% cheaper.
Great.
Thank you.
Okay, guys, thank you so much for staying on. I know it's Monday morning. I wanted to take this opportunity again to thank our panelists, Cary, Craig, and Ionathan, and thank you everyone who joined. And again, if anyone has any follow-up questions, we are available at any point to answer questions on the phone or on email. And we hope to be in touch soon. And we're so happy we're able to speak to everybody today.